Okay, guys, we're going to be looking today at how to calculate the area. These are the most common missed problems that you had, that people made the most mistakes on as you did the stuff on Mathscape. First thing you have to remember when we're talking, I shared this with you also in the circumference video, is you have to be able to recognize what is it they're asking you to find. So here we're being asked to find the area, and they want it correct to the first decimal place, and they want us to use pi, the pi button for pi. So the first thing we want to remember is that when we're looking at circumference, what we said was the circumference was going to equal the diameter times pi, which could also be written as 2 times the radius times pi, which is most commonly referred to as 2 pi times r. We're just using commutative property here. But when we're trying to find the area of a circle is going to equal pi times r, which is called pi r times r squared. These two factors of r. Okay? All right. So we look at this. Notice that we can use the diameter or we can use the radius when we're talking about circumference. When we're talking about area, we have to find the radius. So what might make this problem a little difficult is this right here is the diameter. Remember, the radius is that point from the center of the circle out, which means it's half of this. So it's going to be this distance, which is half of the diameter. So the radius of this is 2 centimeters. So when we're figuring out the area, we're going to say that the area of this would equal pi times 2 times 2, which is 4 times pi. And as it points out, it wants us to make sure that we use pi in our calculation. So you're going to use that symbol pi. And again, we've talked about in the circumference video, if when you put this into a TI-30, if you put that in and it gives you the answer 4 pi, then what you need to do is go to the mode section, hit the mode button, okay, it's going to look like this, it's going to say mode on it, and then you're going to hit the down arrow to where you see the word classic. You're going to scroll down to your reverse video on that and then hit the enter button. It's down on the bottom right of your calculator. Then you're going to get out of that by hitting second mode again, which will quit, and then plug it in again. And when you plug that in, you should get that the area equals 12.5663761. Okay, that's what my calculator tells me. But they told me they want me to correct it to the first decimal place. And many of my students would tell me this is the thing they struggle with the most. How do you round? So that's the first decimal place. So the numbers we're considering here are, is this going to be 12.4? Is it going to be 12.5? Is it going to be 12.6? And what we want to remember is 12.55 rests right there. And our number is 12.66, which rests right about here. So what we're asking when we round is, which one is it closest to? Is it closest to 12.6, 12.5, or 12.4? And we can see by this drawing, it's closer to 12.6. So we would say the area equals 12.6 centimeters squared. Because remember, we're talking about the area. How many square pieces would it take to fill this area? So when we're doing the area, we have to remember that that's this here, everything that's in the inside. What's the area on the inside? That's our area, okay? The circumference measured the strip around the circle. That was our circumference. The area is the orange part inside. So we calculated the area by using the formula area equals pi times r, or pi r squared. Thing to remember is we had a diameter of 4, which means the radius is 2. With the area, you're always trying to find the radius. Okay, so when we look at this problem, again, we're trying to find the area. Okay, so if I'm trying to find the area of the circle, they want me to correct it to be correct to 1 decimal place, and they want me to use pi in my calculations. Okay, so we said that the area would equal pi, the area of a circle, equals pi times r times r. Now, just so happens, this is the radius. The diameter goes all the way across, okay? So we have the radius already. So for us, the radius equals 5. So we're going to have pi times 5 times 5, which means we're going to have 25 times pi. So that means our area of this circle is going to equal 78.53981,634. When I put the actual pi figure, I use that pi key, and I put 25 times pi. This is the number they give us, but they want us to round to the nearest the first decimal place, which means we're going to round here. Okay, so again, if I'm rounding, I'm going to be looking at the number line and saying I'm either going to have 78.4, or I'm going to have 78.5, or I'm going to have 78.6. I want to know which one is it closest to. I look, this is 78.55, and I have 78.539. So that means my number sits right about here. That's where this number sits. So it's closest to 78.5. This is what we mean by rounding down. We say that's 78.5 centimeters squared, because it's area. We're talking about how many square pieces. Okay. Now, if we were calculating the circumference, in other words, we wanted to know the measure around the shape, then circumference would have been, circumference is 2 times the radius times pi, which means we'd have 2 times 5 times pi, which means we'd have 10 times pi, which means we'd have 31.4 centimeters. Now that was for the circumference. That's different than what we came up with for the area. And we were trying to figure out the area, which is how much space does this take up, not how long is the trip around. Area means the area within. Okay. Circumference, we're figuring out the perimeter of the circle. Area is just like with the area of a rectangle. We're trying to figure out how many square pieces it would take. Okay. So you have to be careful. You need to determine, are we looking for area or are we looking for circumference? And you also have to know, do we have the radius? Okay. Okay, look at this. Again, these are from the problems that you most often missed. So as I was looking, Mathscape allows me to go in and see where the mistakes are made. And so I'm looking at what are the ones you missed the most. And this was one of the ones that overall most of the classes seem to struggle with. So the first thing we're going to look at is, well, what are they asking? It says has a radius of a circular baking tray is 9 centimeters. That's the important part right there. We just got told we're finding they gave us the radius. Okay. They want to know the area. That's important. To 2 decimal places, and they want us to use pi. So just overall, just use that pi symbol. If we were teaching it in class and not with using this program, we would probably teach you to use 3.14. But they're asking you to use pi, which could cause some problems for you, which is why I'm talking to you about rounding, because that's usually the biggest problem. All right, so when we look at this, again, what they're asking us is they gave us a circle. Okay, this is a circular baking tray, and it has a radius. So from the middle out is going to be 9 centimeters, right? Okay, so again, we go back to the formula. We're talking about the area of a circle equals pi times r, or pi r squared, which means we're going to have pi times 9 times 9, which means we're going to have 81 pi. So when you plug that into the calculator, you know that the area of this circle is 254.4690049. That's what it says on my calculator. They want me to go to the second decimal place, which means they want me to look right here. Okay, so again, I'm going to round this. And again, if I was looking, I'm going to be looking at 254.45, 254.46, and 254.47. Which one is this number closest to? And if I look, and remember that right here in the middle is 254.465 because it's 465 or 46.5 100ths or 465 1,000ths. Okay, and if I look, 254.469 would be right over in here. That's where that number would sit. So it is closest to 254.47. Okay, so our answer would be that the area is 254.47 centimeters squared. So what we did was we applied the formula for area. Again, remember what we were looking at. When we talk about area, we're talking about what's it take to fill this circle up. That's what the area is. The area is filling it. Circumference is the measure around. It's the perimeter of the shape. Okay, this problem confuses a lot of you. I've seen, this is the one everybody asks. I don't get how to do this. But this is the same as if we had a big piece of plywood, and we cut it into a circle, and then we said, but we only need the trim. We only need, but this is just 5 centimeters. So this is like a washer. Okay, and how much metal does it take to make this washer? So what we're going to do, this is the formula. I would have this written down, guys. I would have this formula written down on my cheat card. You're going to take the area of the big circle minus the area of the small circle, the inner circle. Okay, so the area of the inner circle is right here. So if I were looking at that, I'd say, well, this is, the inner circle is this, has a radius of 5 centimeters. The big circle has a radius of 8 centimeters. Okay, that's from here to here. That whole thing has a diameter of 16 centimeters. Okay, so now so I'm just going to do that, and I remember the area formula is pi times r of the big one, which is going to be pi times 8 times 8, which is 64 pi. The area for the small circle is going to be pi times r, which means we're going to subtract pi times 5, which means we're going to subtract 25 pi. Okay, so now one way to do this is to go ahead and calculate all this now. So I need to figure out what 64 times pi is, and I need to figure out what 25 times pi is. So again, I plugged that into my calculator, and they've told us to be accurate to just put 64 times pi, which gives me 201.0619298 minus 25 times pi. So I just put 25 times, hit the pi button, hit enter, and that says 78.53981634. Now, we've been rounding, right? So when I round, and they want me to round to the nearest 1 decimal place, I'm going to round here and here. Okay, so this is going to be 201.1 minus, this is going to be 78.5, which means it's 122.6 centimeters squared. And what we found was what this area here is, what this green shaded area is. Okay? Okay, so bottom line, if you can do this, you got it. I'm going to show you a shortcut. It's not a big shortcut, so if it goes over your head, don't sweat it. But guys, if we remember our algebra, if we go over here and we say, well, what would 64x minus 25x be? Well, so really what we're saying is we're going to subtract 64 minus 25, which is 39. So we have 39x, right? Well, instead of x, we have pi. So if we have 64 pi minus 25 pi, that's going to be 39 times pi. And if I plug that into my calculator, then I get 122.522, and on and on. So it's going to be 122.52. So that brings up the question. Well, this is going to round to 122.5 centimeters squared, which is different than 122.6. And some of you are having that problem when you calculate. Well, so if I take 201.0619298 minus 78.53981634, then I get this. So if you're rounding too early, which we did here, If you round too early, that's where you're getting that 0.6. So if on the computer, there's nothing wrong with that. 0.6 of a centimeter versus 0.5 of a centimeter, that's 0.1 centimeters difference. But if you're getting the same, if you keep getting 0.6 and you're getting it wrong, then subtract the two full numbers. It's going to be exact. They've used when we've, all three of us as your seventh grade math teachers have asked the question, why are they making mistakes here? And I think that's the key. Is they said, their response back to us was, you need to be exact. And I think that's what they're doing, and they've not put in that another possible answer could be 122.6 centimeters squared. So maybe part of the thing is you got to put in that whole number there. But if you understand what I just did over here, if you understand this, well, you're going to get the answer right more often. But if you don't, you could still get the answer right by just taking those two full numbers. And if it wasn't math space, we would probably be accepting 122.6 centimeters squared. But you got to be really accurate with this program. When we look at this shape, we're going to do the same thing over again. But this was another one that people were struggling with. It's the same thing, except for this time they gave us the diameter. So we need to remember that what we're looking for is the radius. So we want to know this radius, and we want to know this radius. Well, the radius is half the diameter. So if the radius is half the diameter, means that's going to be this part, then what we have to know is that if the diameter is 18, then the radius should be 9 centimeters. And if the diameter is 22, then the radius is 11 centimeters. So you have to remember that, but then we're just going to do the same thing over again. We're going to say the area of the green, the area of the big, minus the area of the inner, or the small, or the whole, the part we're taking out, right? Because we're going to take this part out. We're cutting this part out. So again, if we're doing the area of the big, then the big is going to have a radius of 11 centimeters. So we're going to have pi times r, which is going to be pi times 11 times 11, which is going to be 11 times 11 is 121 times pi, which comes out to 380.132711. Okay, then we're going to subtract from that the other pi times r, because that's how we figure out the area of the circle. And we're doing the inner circle, which has a radius of 9 centimeters. So we're going to have pi times 9 times 9, which is 81 times pi, since 9 times 9 is 81, and which is going to give us 254.469049. So to be exact, like they've asked for it, then what we're going to do is subtract 254.469049 from 380.13271, and that's going to give us 125.663761. They want us to calculate to the nearest one decimal place, so that's to the nearest tenth, so that's going to be here, and that's going to round to 125.7 centimeters squared. Now again, I don't want to confuse you, but if I would have bypassed and gone over here and said, well, what is 121 pi minus 81 pi? I would have gotten that would be 40 pi. And 40 times pi is this number. So it just skips one step. If you can understand it, then be careful. But if you can understand it, then it saves you a step because you still would have gotten this number, and then you would have had to round it down to 125.7 centimeters squared. If you don't understand what I did here, just calculate, subtract the actual numbers, and you'll get the same answer. Okay, so the difference between this one and the one we did here is on the first one we did, they gave us the radius. On the second one we did, they gave us the diameters. If they gave us the diameters and we have to find the areas, which they told us they wanted us to find the areas here. Okay, if they give us the diameter, and the first thing we have to do is figure out what the radius is. If they gave us the radius like they did in this problem, well, then we don't have to work that hard. And so you have to be able to discern between did they give you the radius or did they give you the diameter? And you have to be able to discern, are they asking me for the circumference or are they asking me for the area? If they're asking you for the area, you need the radius. If they're asking you for circumference, you can do it with both. But if they're asking you for the area, the formula for area is pi r squared, or pi times r, and then you have to find the radius and then calculate with the radiuses. All right, guys. Well, let's try this. I'm going to give you a couple practice problems here. So look at these two problems, and let's see if you can do these two problems. Okay, so I'm going to pause it, or you should pause it, and then calculate the problems, and then pull it back up and see if you got the right answers. Okay, so on these two problems, you should have come out on this first problem. They wanted you to round to the 2 decimal places. So you should have come out with 78.54 centimeters squared. Okay. You would have just calculated that your radius was 5 centimeters. The formula, you would have written out the formula, plugged it in, and that's 25 times pi. And then from that, you get 78.54 centimeters squared because we're rounding to the nearest hundredth place value. I taught you that when you do these, when you cut it, when you look at this, you're just finding the shaded area. When you look at this shape, you're going to take the area of the big circle minus the area of the small circle, or the piece that you're cutting out. They both have the equation pi times r times r. So you would have wound up with 81 pi minus 36 pi, which gives you 254.46900049 minus 113.09733355, which would have given you 141.371669.4. They asked us to round to the nearest 1 decimal, so the nearest tenth. So that would give us 141.4 centimeters squared. Okay. Again, with this problem, if I would have just looked over here and said, what's 81 pi minus 36 pi? That would have given me 45 pi which would have given me 141.37166694, which then would have rounded to 141.4 centimeters squared. Okay, hopefully you're getting this. These are the problems that you struggled with the most as I looked at the results from every class period. These are the problems you struggle with the most. I hope this helps. Good luck.